Okay, the top part of this assignment, I told you that you did not have to do it. So to start with, you're on number 6, and for the x values, you're going to use -2, -1, 0, 1, and 2. And all you're going to do is plug those numbers in place of x. So I'm going to plug -2 in for x here as the exponent. And if you do that, there's some online calculators if you don't have one at home that would do that for you. And if you actually did that, you'd get 0.4. So you plug in -2 and you get 0.4. If you plug in -1 as the exponent, this is all f right now, and you'd get 0.6. If you plug in 0, you end up with 1. If you plug in 1, you get 1.5. And if you plug in 2, you get 2.25. And then for g, now you're going to take these x values and plug them in for g. So you're going to type 0.5, or you're going to type 1/2 times -2 plus 2, and you get 1. And you're going to do that again, except you're going to type in -1, and you end up with 1.5. Then you end up with 2, 2.5, and 3. So on this, it then asks you about the greater rate of change. And I told you that I'd be happy if you just went through and found the rate of change for each one. On this side, it's going by 0.5 every time, which is nice and easy to figure out. If you're going here, that's up 0.2. 0.6 to 1 is 0.4. 1 to 1.5 is 0.5. And here, 2.25 minus 1.5 is 0.75. So if you look at the numbers in red, and I know it's hard to see, there's not a lot of room, but if you're looking at these numbers, notice here is when they're exactly equal, rate of change is equal. And if you're below the number 1, so if you're below the number 1 up here, then notice that g of x is bigger. And if you look on the graph, you can see that. Here's your 1, where they're the same. And if you are over in this region, do you see that that straight line has a greater rate of change, or it would be harder to climb up? So g of x is bigger over here, or a greater rate of change, and over here fx has a greater rate of change. I do have to get rid of some of this to do the next one. So next we are going to do the same thing. So you're going to type -2, -1, 0, 1, 2, and we're going to plug those in, starting with f. So it's going to be -3 to the power of -2, and then plus 1. We get 0.8 repeating, which rounds to 0.9. You do the same thing, but you plug in -1. You're going to get 0.6 repeating, which rounds to 0.7. If you plug in 0, you get 0. If you plug in a positive 1, you end up with -2, and then -8 if you plug in a 2. So then you do the same thing, but now you're going to plug the numbers all into g. So -2 times -2 minus 2 is just positive 2. We can see that this is just subtracting 2 every time. So -2 is 0, -2 is -2, -4, and -6. And from here, again, you would go through and you would find the rate of change. Notice here, g of x is real easy because it's just subtracting 2 every time. If you go to fx, though, here we got 0.2. From here we got 0.7 to 0. It's 0.7 away. Oh, it's going down. These are going down. 0 to negative 2 is negative 2, and negative 2 to negative 8 is negative 6. So notice about right here is when they are equal. So that's at 0, 1, right in this region here. So if we are looking at these numbers, do you see that there's a 6 and compared to a 2? So if we are bigger, we're looking at the numbers bigger than 1. So if we're on this side of the graph, notice that fx, or the curved line, has a bigger rate of change. So we'd put fx is growing faster here, whereas if you're top up here in the smaller x numbers, then notice this g of x, this straight line, is growing faster, or it's steeper or harder to climb. Okay, and then you're going to do the same thing. You would do it with this one, negative 2, negative 1, 0, 1, 2. Plug them in. So that's just 2 to the x, I think. It's hard to see on this board. So that's 0.25. It's timesing by 2, so 0.5, 1, 2, and 4. And then 8x, so that's negative 16, negative 8, 0, 8, 16. So again, we would go through and we'd find the rate of change between every single point that you're given. And here, that's 0.25. This is 0.5, 1, and 2. Here we've got 8, 8, 8, 8, the whole way through. So in this case, with the numbers that we see here, we would actually have to keep going to see that the curved line, the exponential, is gonna be bigger, but it's not bigger yet. So even to the number 2 here, the straight line, the fx, is still the line that wins out the whole time, because if you look, they're all 8s compared to 2, 1, 0.5, 0.25, so greater rate of change. So number 9, it says write the explicit equation for the table. And if you look at this table, it is, and on this side it's just going by ones, so we can just focus on what are these numbers doing here. They're subtracting 7 every time. So we know that the slope is 7. It has to be y equals mx plus b, because this is linear, because it's subtracting. And so what we try to do now is to use the 0 term. And if we don't have the 0, we're going to go back and find it. So to go backwards, we're going to add 7 and get 3. And we're going to go backwards and we're going to get 10. So in this case, we're going to have y equals negative 7x plus 10. On this one, notice, okay, the x's go by 1, so that's all good. And here, 2 to 10 to 50, that's getting pretty big, and this is multiplying by 5. And therefore, we need y equals b times a to the x. We need exponential. The 0 number is 2, and it's timesing by 5 to the x. And that's it. 11. So here the pattern is multiplying by 2 every time. And if you're not sure, you could try subtracting them and see how much that is. And if that works, and if it doesn't, then try dividing. And then here again, we don't have the 0 term, so I'm going to go backwards, and I would divide 2. So that's negative 12. And again, I would do it one more time, so that's negative 6. And I would write y equals the 0 term. It's times 2 to the x. On here, the numbers are going up. It's hard to see it because they're negatives. So 0 would come next, and then a 1, and then a 2, and so on. 81, 27, 9, and 3. These numbers are dividing 3 every time. So if you keep going and you divide 3 again, we'd get a 1. Divide 3 again, we'd get 1/3, 1/9, or 0.3 and 0.1. And so our equation, again, remember, dividing 3 is the same as multiplying by 1/3. So the 0 term is 1, and it's multiplying by 1/3. So y equals 1 times 1/3 to the x. On the next part, these are your axes right here. And because it's linear, we need y equals mx plus b. And if you notice, the b value is 2. It's the y-intercept. And if we want the slope, we pick any 2 points and find the rise and run. We go up 1 over 3, so 1 over 3. And that line is going down as you go across, so it's y equals negative 1/3 x plus 2. Notice this line is exponential, so y equals b times a to the x. The b value is 1, as you can see here. And if you go from 1 and it hits again here, 1, 2, 3, 4. If I go from 1 to 4, what do I have to multiply by? I have to multiply by 4. 1 times 4 is 4. So it's y equals 1 times 4 to the x. Here again, same thing. Rise and run, 1 and 1. But if this is y equals mx plus b. Hopefully you caught that part. It's not exponential. So it's linear. 1 and 1. 1 over 1, though, is the same as just 1. That line is going down. So negative 1x is negative 1 is our slope. And the y-intercept point is a positive 1, so plus 1. Here, this is y equals b times a to the x. This point, the b value, the 0 term, the y-intercept, is 0.5, or you could put 1/2, either way. So if it goes 0.5 and then it hits at 1, and then it hits at 2, and then again at 4 here, and then I keep going and it hits at 8. If you're going from 1 to 2 to 4 to 8, that is multiplying by 2. So y equals 0.5 times 2 to the x. Here, this is linear, mx plus b. And it hits, if you see, these are your axes, the x and the y right here. So notice it hits down 1, 2, 3, 4. So we know that the b value is minus 4. The slope, up 4 over 1. So 4 over 1 is just 4. And that line, as you go across the board from left to right, is going down. So it's negative 4x minus 4. 18, if you didn't hear it in class, please cross out 18. You do not have to do it. On the bottom part here, y equals 4 plus 3x. That's y equals mx plus b form, so it's got to be linear. If it's linear, it's going to be arithmetic, straight lines. And then over here, same thing, y equals 4 times 3 to the x. It's got an exponent, so it has to be exponential. And again, that's going to be geometric. If you look at your graphs here, notice that they only have positive values. And so for x, I would do 0, 1, 2, 3, 0, 1, 2, 3. And notice that your 0 term, you got y equals 3x plus 4, or the way it's written, 4x plus 3, or 4 plus 3x. The 0 term is 4, and it's adding 3 every time. So 7, 10, 13. Our slope, or m, rate of change, is 3. Over here, we had y equals 4 times 3 to the x. So in that case,